All right, everybody. So today we are taking a look at 3.1.1. How can I simplify it? All right, so we're starting with Chapter 3, Grouping Expressions. All right, so here's what we're going to be learning about today. First off, the order of operations, which is understanding the order of simplifying expressions. And when we do this, we're going to need to find numerical terms in our expression so we can divide it into parts. And then finally simplify at the end. All right, so starting off with numerical terms. Over here we see in green it says each group of positive tiles is represented by a different part of the expression, also called a numerical term. Numerical terms are single numbers or products of numbers. It is often useful to circle terms in an expression to keep track of separate calculations. For example, each term circled in the expression below represents a separate part of the collection of positive tiles above. All right, and so let's take a look at what it's saying here. It says here we have 5, that's standing alone. 3 times 4, that doesn't stand alone. We have to do an operation here. So that would be a numerical term. And then finally 2 stands alone. So those would be our 3 numerical terms. And then if we look over here to when we actually simplify that expression, we're going to start off by doing 3 times 4 because that's not by itself yet. When we do 3 times 4, we get 12. And now look at this. We have 3 standalone numbers that we can just simply add together and arrive at our answer of 22. So 22 would be the simplified version of this expression right here. Trying to figure out how to go to the next slide here. There we go. Awesome. So now we're looking at the order of operations. And so we're going to watch this epic video right here. I don't think it'll play out my smartboard right now, so I'm actually going to play this during our Zoom meeting. Otherwise, please watch it right now if you can pull up that slideshow. It's a really great song for remembering. All right, I'm not going to lie. I absolutely love it. Moving on to the next slide here. Order of operations is basically just a way that we can get from this crazy expression that we see up top here and just say that that expression is 15. It's the same thing, except we had to go through a series of steps to go from that crazy expression we see up top all the way down to 15. So we're going to learn what those steps are. All right. So here we have PEMDAS. Your parents may know it as please excuse my dear Aunt Sally, but basically it's a way of remembering how you can simplify an expression. All right, so here is what PEMDAS stands for. First off, it is parentheses. So you're going to take a look at what is inside the parentheses. We show parentheses with the 2 lines that look like this on the outside. And then next, you're going to look for exponents. Now, if you look up here at our diagram, exponents is when we have a number, and then it has a smaller number in the corner of it. So it might look like 5, and then a 2 up top like this. That means 5 to the 2nd power. Okay, so that's exponents. Next, we're looking at multiplication. Multiplication, you're going to see like we have here in our expression, typically represented by x. You also may see it as like 5 and then in parentheses 3, or 5.3, or 5 times 3. Those are all ways that we can show multiplication, okay? And then we're going to look for division. So division would be like what we see here, 4 divided by 2. And when we do PEMDAS, we're looking at multiplication or division. And so we're going to look from left to right, starting here, and making our way to the right. Meaning if we see multiplication come first, like we see here, then we would multiply. But if division came first before multiplication, then we would divide first, okay? So these two are interchangeable, multiply or divide, whatever comes first from left to right. And then we have adding and subtracting to finish it off, okay? So basically, if we do what we did on that last page, where we take all of our numerical terms, like 5 times 3, for example, and put them into standalone numbers, 15, then you can simply add and subtract all of your numbers here in the expression that are left. All right? So here we're going to do a few examples. All right. So we look at our order of operations, thinking about what we're going to be doing first. Our equation's over here in pink. So we're going to start with parentheses. Do we see any parentheses in this problem? Yes, we do. We see parentheses right here. Trying to get it in a different color. Oh, I know why, because I got my red over here. Okay. Let's go yellow. So I'm going to go parentheses here. So I'm going to first do what's inside the parentheses, 7 plus 3. There we have 10. And then I'm actually just going to rewrite everything that's after it exactly how we see it. So it's 10 times 4 divided by 2 minus 5 times 6. So we're rewriting after every single step. So parentheses, check. Now we're looking for exponents. Do we see any exponents? Again, that's when there's a number with like another number up above it. Well, I don't see that in our expression to the right. And so now I'm going to look for multiplication. Do I see any multiplication? Ooh, yes, I do. So here I see it as 10 times 4, because notice these are together now. 10 times 4. So if we do 10 times 4, we're going to get 40. And then we're going to rewrite everything just as we see it. Every single time we're going to rewrite. And then look at this. I also have more multiplication here. So I'm going to do my 5 times 6. So now we're going to have 40 divided by 2 minus, and then whatever 5 times 6 will give us, 30. And so now we have to do the next step here of division. 40 divided by 2, that's going to give us 20. So we're left with 20 minus 30. So if we do 20 minus 30, that would bring us all the way back to negative 10. And that would be our simplified version of this entire expression we see here. And we got to that simplified version by following these steps, starting with parentheses, exponents, multiplying or dividing, and then adding or subtracting. In this case, we finished with subtraction. All right. So now that we know the process, I am going to have you guys give it a try yourselves. Trying to go to the next slide here. All right. So here we have the expression 7 plus 3 multiplied by 5. So according to PEMDAS, right, starting from parentheses and working our way to subtraction, which of the following answers is correct when you are simplifying this expression? So is it going to be 7 plus 3 first to get to 10, multiply that by 5? Or is it going to be 7 plus and then whatever 3 times 5 would equal? So is it 10 times 5 or is it 7 plus 15? Think about which step would be correct first. All right, hopefully you guys have had some time to figure it out. So let's figure out what the answer is. 22 is correct because you would multiply before adding, right? We see multiply, it's our third step after P and E, and then we have adding at the very bottom, right above subtraction. So multiplying first. All right, now we're looking at simplifying using PEMDAS, all right? So notice I do have this little sign here. That is a multiplication sign, so you can think about this as 5 times 4. I just don't like to use x. And so let's simplify the following equation using PEMDAS. All right, so if you've had some time to do it, you're going to first look for parentheses, right? Where do I see parentheses? Oh, I see them right here. So I'm going to do what's inside the parentheses and get 6. And then I'm going to rewrite everything exactly how I see it. 5 times 4 plus 6 minus 6. All right, now I'm looking for my exponents here. Do I see any exponents? I do not. So first two are check. Now we're looking for multiplication. Ooh, I do have some multiplication here. 5 times 4. That's going to give me 20 plus 6 minus 6. And now I'm looking for division. I don't have that at all. Now I'm looking for addition or subtraction, whichever one comes first from left to right. So here I have addition that comes first. 20 plus 6 gives me 26 minus 6. My final step of subtraction gives me 20. All right, so this big expression up here is the same thing as 20. Just had to go through our steps. All right, let's see if I can go to the next slide without any issues here. Almost, we're getting there. All right, nice. So now we're going to be learning about what exponents are, because that's a step that we haven't really seen a whole lot of yet, but it's definitely an important step to understand. All right, so if we look at the expression up at the top of the board, well, this is difficult to erase. So the expression at the top of the board is, in parentheses, 6 plus 2, and then we see this 2 right above all that. All right, so what does that 2 mean above the 6 plus 2? And then we divide it by 4 times 2 minus 3 plus 1. Okay, so as far as exponents go, we have our example here of 5 with the 2 up above. So this 2 is saying that we multiply 5 twice. All right, and there we see our example, 5 times 5. So 5 to the second power, or 5 squared, would be the same thing as 5 times 5, give us 25. All right, so a little bit more on exponents here. We have what is called our base. And so if we look at the diagram on the right side of the screen, 6, that would be our base, and then 3 would be our exponent or our power. And so it's saying that we start with 6, and then that number in the corner tells us how many times we multiply it. So we multiply 6 by itself, 6 times 6 times 6. So basically exponents, that's referring to repeated multiplication. Just like multiplication, where that's referring to repeated addition. All right, so addition, and then comes multiplication, and then after multiplication comes exponents. These are just quick ways for us to do them repeatedly. And this is just going over exactly what we talked about. So the exponent tells you how many times, or the power I should say, tells you how many times you are multiplying that number. And the base is the number that you're multiplying by itself. So go ahead and give it a try here. If our base is 4, the number that we're starting with, and the power is the number we're multiplying it by itself, or how many times we're multiplying it by itself, how would we rewrite 4 to the third power? Or 4 cubed, you've maybe heard it called. All right, so here you should have gotten 4 times 4 times 4. So this is our base number, the big number we're going to be writing. And then this tiny number up top, our power, that's telling us how many times we are going to be writing it, or multiplying it by itself. And so here, if we solve this, we do 4 times 4 gives us 16. And then if we multiplied 16 by 4, then we would get 64. All right, moving on to the next problem. How would we write this? All right, think about what number we're going to be rewriting, and then think about which number tells us how many times we're going to be rewriting it. Our base and our power. All right, so here we're going to be multiplying 7 by itself, and we're going to be multiplying it by itself 3 times. So 7 times 7 would give us 49. And then if we multiplied 49 by 7, well, let's think of what 50 times 7 is. That would be 350. And then we're only doing it 49 times, so instead we're going to be subtracting 7, and we'd end up with 343. All right, so that would be what this would equal if we had to solve for 7 cubed or 7 to the third power. All right, now let's go ahead and actually solve this problem that I talked about earlier. So it says 6 plus 2 in parentheses, and then raised to the second power, so we have an exponent, divided by 4, multiplied by 2, minus 3, plus 1. Think about our order of operations here. Start with parentheses, end with subtraction or addition. All right, so let's go through it together now. Let's take a look at our parentheses. We do see parentheses to start, actually. 6 plus 2, that's going to give me 8. So now I have 8, and I still have this 2 right on the outside. So 8 to the second power, or 8 squared, divided by 4 times 2 times, or minus 3 plus 1. Notice I'm rewriting this exact same part of the expression. All right, I'm not going to try to shortcut anything and do multiple steps at a time. So next I need to do my exponents. Well, here I see 8 squared. So let's see, 8 times 8, that equals 64, right? Because exponents tell me I'm multiplying it by itself. And then we still just rewrite everything as it is. Going to be a lot of rewriting, all right? And then we have multiplication or division. Whatever one comes first from left to right. I'll do this in red. So let's see, which one comes first? Division comes first, actually. And so if we do 64 divided by 4, well, if we do 40 divided by 4, that's 10. And then there's 24 left over. That divided by 4 is 6. So 10 plus 6, that gives us 16. And then we rewrite everything as it is. So now I'm looking for multiplication, right? Because we skipped over that because we saw division first. And we're going to do 16 times 2, which is 32. Rewrite everything as it is. I know it's tempting to just do 3 plus 1, but that's not the order we do it in. All right, next we're looking at addition or subtraction. Which one comes first? Well, subtraction comes first. So we're going to do 32 minus 3 gives us 29. And then we still have our plus 1 here. And so then we're going to end with addition. And if we do 29 plus 1, that's going to give me 30. So our final answer here, when we simplify this entire expression, is going to be 30. Pretty cool how we can go from all of this just to 30. And we can say it confidently because we followed our PEMDAS. Parentheses, exponents, multiplication, division, adding, subtracting. Remember, whichever one comes first for adding and subtracting, that is our order that we do it in. All right, we're almost on to the core problems for today. All right, here we are. So open up your book to 3.1.1, and we're going to go over the core problems together. That is page 131 in your textbook. And there's only 7 problems here, 1 through 6. Actually, 6 problems, I take that back. All right, so here we have, Katrina wrote the following set of instructions for Cecil. 4 times 2.5 plus 1. Actually, you know what I'm going to do?